Hi, everyone, and welcome to another science lesson with Mr. Jackson. Today, what we want to do is talk about the four types of chemical reactions that most commonly happen. So, for these types of chemical reactions, we have these guys right here. The first one's going to be synthesis, kind of like many stormtroopers. The next one is decomposition, kind of like Darth Vader tearing someone apart. Then we have single replacement, kind of like what happened in Indiana Jones. And then finally, double replacement, kind of like, I don't know, in a sports team, people being replaced during a substitution. So what we want to do is talk about these types of reactions. So first, we have a joke for the day. Did you hear the one about oxygen and magnesium? They were going out, and I was like, oh. Okay. Anyway, so here's what we want to do. I'm going to talk to you about those four types of reactions. So what you want to do is kind of sit down and relax, pretend that we're telling stories by a fireplace, grab yourself a nice hot cup of cocoa. It's even better with a candy cane in it. And if one candy cane's good, well, you might as well put a couple more in there. But relax and let's talk about these four types of chemical reactions that commonly happen. So for all of these stories, there's kind of like a regular story. There's something happening in the story that's going to be happening over here, and then there's an equals. In science, we call that the yield sign. So instead of just like in math class, an equal sign, there's a little arrow right there, but they mean exactly the same thing. And then there's an end to the story. So let's practice. We could say, okay, Thanksgiving, right? We had lots of turkey for Thanksgiving, or at least some people did and everything, right? Plus stuffing, right? Equals.
And now, cookie.
Okay, a whole lot of eating and dieting probably ensues later after. Okay, so the first type of reaction, right, is going to be a synthesis reaction. Right now, you know it's a synthesis reaction above all the other types of reactions because there's a plus sign over here. There are going to be things on both sides of it. There's the yield sign, what you think of as the equal sign, and then something happens, right? To synthesize means you're putting things together. Kind of like a synthesizer, right? If you're making music, let's say if you're an artist making music, you synthesize it, right? You have a recording of someone singing over here, and you have a recording of drums here and guitar there, and it all gets synthesized or put together into a beautiful song kind of thing. So in our case right here, we've got a foot, right, as our kind of fun example. I've got a ball over here. What do you think it's going to synthesize? When you put those pieces together, well, it's going to make a football, right? Of course it's a football. Well, okay, that's not really a football, right? For some people here in America, it's football, but for the rest of the world, this is a football, proper football. But anyway, you get the idea, though, right? Football, you have a couple things, right? They're coming together and they're making something. In the real chemistry world, as an example, right? Let's say you have hydrogen. Let's say two hydrogens over here, plus an oxygen. I bet you see where this is going, right? That yields H2O, right? That's a synthesis reaction right there. Pieces coming together to make a whole thing. Or let's do this. How about this as a short little video? Here's someone synthesizing something, right? They have a whole bunch of little tiny pieces coming together to make one really big thing, right? So that's synthesizing for it. Now, the opposite of this is called the decomposition reaction. So same thing, it's a type of chemical reaction, also very common. But here it's the exact opposite. Look, there's a blank here, but then comes the yield sign, what you think of as the equal sign, and then there's two places, something plus something. So it's the exact opposite. Something's being pulled apart. So in the chemistry realm up here, we've got one whole H2O molecule right here, but it's yielding, look, if it breaks apart, hydrogen on this side, plus oxygen on that side, right? If you saw one of the earlier videos in the last chapter I did, this was the electrolysis experiment. We started out with water molecules, they got zapped with electricity, right? And that literally splits them apart. So you have hydrogen bubbles on one side and oxygen bubbles on the other side. Or if we go back to the example down here, the fun example for science, how about an egg on one side? Oh, I bet you can see where this is going. After the reaction, well, you could have shells on this side. That sounds terrifying for that little chick. But anyway, then the chick on the other side, right? So you have the pieces of the same thing over here, right? On this side, it was something whole. Over here, it splits into little tiny pieces. So that would be a decomposition reaction. So synthesis, little pieces are coming together to make one big thing. In decomposition, one big thing is being split apart into little tiny pieces. Okay, so those are the first two simpler ones. And here's my decomposition video for you. You have one really big thing, right? Let's say a bunch of Legos being torn apart by I don't know, your angry little sibling or something like that. Ironically enough, here's a picture of a decomposition reaction actually happening. We have the reactant right over here, but then it breaks apart into smaller segments over here. So scientists are actually able to zoom in with very special microscopes and be able to see this happening. Oh, and then we have this cartoon right here. I thought, the chemical formula for water was H2O. Get it? Oh, I thought that's fun. Okay, the main chemistry joke of the day. Do you want to hear another chemistry joke? How about sodium? Some of you are probably like, nah. Get it? Sodium? Nah. Oh, okay. Never mind. Moving along. Okay, we're halfway there. Right now, there are two other types of chemical reactions that commonly happen. They're both replacement reactions. So the easy way to tell if it's one of the two replacement reactions is, look, you've got the yield sign in the middle this time, but now you've got at least one plus sign on each side. You could actually have multiple plus signs on either one or both sides. So you've got little pieces over here and little pieces over there. Right. So in our chemistry example right here, we've got some hydrogen and carbon over here plus titanium yields. Well, now you have titanium and carbon and hydrogen alone. So what's happened is basically the carbon has switched places, right? Carbon over here was attached to hydrogen, but after the chemical reaction happens, now carbon's attached to titanium, which naturally, because titanium is so cool, right? It's a single replacement because, look, there's one element that's all alone. It's single over here, right? Over here, same thing, an element that's single. And for a single replacement reaction, as long as you can see any one type of element all alone, that means it would be single replacement. So it could be, let's say, it could say hydrogen. There could be like 10 hydrogens here. It could say H10, and over here it might say H10. It would still be single replacement because it's just hydrogen, right? So it doesn't have to literally be just one atom. It just has to be one type of atom all alone. Right, so it's a replacement reaction, plus over here, plus over here. It's a single replacement because anywhere it could happen on both sides or on one side, as long as there's one element that's all alone and single, that by definition makes it a single replacement reaction. So let's go down to the colorful version, right? The fun version. I've got a dog with a bone on this side. That's a funny sound. Over here we've got a steak, right? Now, chemical reaction happens in our short little story, or let's say they mix together and they rearrange. Now, the bone is the thing that's all alone, and you've got the dog. Hold on here. Here we go. Whoa, hold on. Wait. Hold on. Technical problems. My computer locked up on me. Okay, here we go. So you have the dog with the bone, you have the steak, you have the bone all alone, and over here, the dog, but with the steak. All right, so dog with the steak. So what's happened is the bone and the steak have switched places, right? So over here, the bone's together with the dog. Over here, the bone's all alone, right? So as long as you have steak all alone or bone all alone or both, that makes it single replacement. And in our video, all right, here we go. Single replacement, right? Indiana Jones right here. And there it happens. One thing gets replaced, right? That's single replacement. Okay, we're coming down towards the end of our story time here. There is but one type of chemical reaction that we need to talk about, and that is the double replacement reaction, the granddaddy of them all. Now, for these double replacement reactions, it's a replacement reaction because, look, plus over here, plus over there, right? So there's at least one plus sign on both sides of the yield sign, right? And in the chemistry version, right, what the only real difference is no one type of element is all alone, right? So over here, you've got sodium and chlorine right there together, hydrogen and oxygen. No one element is all alone. So you're thinking, okay, it's not single here. A check on the other side. Hydrogen and sodium, oxygen and chlorine. No one is alone. That's all you need to know, right? That makes it double replacement. So you can, if you're trying to identify these, plus over here, plus over there, no one type of element is all alone anywhere. That makes it double replacement right there. So in our example down below, we've got our good friends again, bunny and puppy, and the things that are being replaced, we've got bunny with steak, which, that's just funny right there, right? And dog with carrots, right? But after the chemical reaction happens, well, look, the food changes places. There's bunny with carrot and then dog with steak. It still doesn't look right now. Anyway, so that makes it double replacement right there. You've got two plus signs, right? One on each side of the yield sign. And no one type of thing is all alone. Something has got at least two partners with it all the time. Oops. And so here's the video version. right? You've got two people going in, one people coming out. It's pretty messy, and this guy was about to come out, but I cut the video too short. Sorry. This is like the worst, substitution in sports history right here, where everybody falls over. Okay, so let's try to practice. Are you ready to practice a little bit here? So if I give you this one right here, this is going to be kind of like what will happen on the assessment a little bit later, right? You've got a chemical story going on here. There's a chemical formula happening, before your very eyes is a chemical reaction. You need to tell me, is it synthesis? Is it decomposition? Single or double replacement? Well, look, there's only one plus over here. There's no plus over there. So it's not one of the two replacements. You're already down to a 50-50 shot about it, right? So what you need to tell me is basically, is it synthesizing something or decomposing something? And look, there's one big thing going on over here, and it's breaking up into little pieces. That's decomposing. Woohoo! Decomposing, right? For it. How about this next one right here? Okay, for this chemical story happening right here, plus sign over here, plus sign over there. So, okay, it's one of those two replacement reactions. The only question is it a single or double replacement? And remember, all you need to find is there one type of atom all alone? And look, right here, oxygen. Oxygen is all alone. Oh, the lights all went out. Hold on one second. I'm back. So since oxygen is all alone there, it's going to be a single replacement reaction, right? Single replacement. Next one. Okay, it's definitely not a replacement reaction. Plus over here, no plus over here. So it's decomposition or synthesis. And look, it's two pieces, two separate chunks combining together to make one thing right there. That means it's going to be synthesizing. It's building something, kind of like Legos. Let's see. Is this? There's another one right here. Plus over here, plus over there. It's one of the two replacement reactions. And then all we need to figure out, single or double, is there any one type of element all alone? Sodium and iodine, hydrogen. Okay, these guys are all together. It's going to be double replacement. No one type of element is all alone. A double replacement reaction. And we'll try this one. This will be our very last one. We're at the very end here. Okay, which one is it going to be? Plus over here, plus over there. It's one of the two replacements. Is anyone all alone? No. No. Okay, so far it's going to be double, double, double. Yes, it's going to be double replacement. Everybody has a friend. All right, remember to take the short little quiz. Hopefully this helped.